Hi everyone, welcome back to Data Mining Video Lecture Series. And this is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology. In this lecture, we are going to discuss the two techniques. One is attribute subset selection, and then the two other parametric methods like regression and log linear models. So in this lecture, we are going to cover mainly the basic heuristic methods of attribute subset selection. There are basically the three methods. We'll discuss in detail about those three methods. And then the parametric methods, one is a regression and another one is a log linear models. As we already discussed in the previous lectures about the dimensionality of data sets. So data sets may contain the hundreds of attributes in the real world. So many of those attributes may not be relevant, or many of the attributes are irrelevant to the mining task, or many of the attributes may be redundant. So it reduces the data set size by removing the irrelevant or redundant attributes or the dimensions. Attribute subset selection reduces the data set size by removing irrelevant features or dimensions or redundant attributes. For example, if the task is to classify the customers based on whether or not they are likely to purchase a popular new CD at all electronics when notified of a sale, and here the attributes such as the customer's telephone number, these are likely irrelevant, unlike the attributes such as age or the music taste. So the goal of attribute subset selection is to find a minimum set of attributes, so such that the resulting probability distribution of the data classes is as close as to the original distribution that is obtained using all attributes. So the mining on that reduced data set or mining on a reduced set of attributes has additional benefits. Mainly, it reduces the number of attributes appearing in the discard patterns, and also it helps to make the patterns easier to understand. And how we can find a good subset of original attributes. For example, there are n attributes in a data set, and there will be 2 to the power of n number of possible subsets in exhaustive search. So you can see, like the number here, the number of classes increases, the complexity would become more. Like here you can see where n value is, like let us say here n equal to 1, 2, 3, 4 like this. You can see the big numbers in this. So this is a very complex number. That is mainly when the number, that is n, increases. We'll discuss in detail about this, the power set and the complexity, and how the search space would be reduced in detail in a frequent item set mining. So here we can find a good subset of original attributes by applying this attribute subset selection. So that 2 to the power of n, for example n equal to 100, then the 2 to the power of n will be a big number. So that's why this exhaustive search, that is to check, like suppose here in this 2 to the power of 100, it's a big number. It is very expensive to search the potential attributes in this 2 to the power of n number of subsets. So we need to rely on the greedy methods. or those are mainly like a heuristic methods. One among those is a greedy method. In that, the greedy method, while searching through, it always makes what looks to be the best choice at the time, that is local minimum. So this greedy method mainly works. The strategy of this greedy method is mainly it make a local optimum choice in the hope that this will lead to a globally optimal solution. So that's why the greedy method is more effective in practice. So the best or the worst attribute subset selection, the best or the worst attributes are typically determined using a test of a statistical significance. So we are not going to discuss in detail about this statistical significance, based on the assumption that all attributes are independent of one another. And if you look at the heuristic methods, that is to find the set of attributes, we have mainly the four. One is a stepwise forward selection, second is a stepwise backward selection, and then the third combination of both forward selection as well as backward selection, and the fourth one is a decision tree induction. So let us quickly see all this a little in detail. For example, if you look at the stepwise forward selection heuristic approach, how it is going to identify the attribute sets. So it begins with that is the reduced set, initial empty set. It initializes the reduced attribute set to be an empty set, and it selects the best attribute in the initial set using a statistical measure. And there will be a threshold that we will discuss end of this. Then that is where to stop this subset selection. So we have to check that condition here. So does the selected attribute exceed the stopping threshold or not? We have to check. If it's so, then we have to add the selected attribute to the reduced attribute set. If not, then it will be ended. And suppose if we add the selected attribute to the reduced attribute set, and again we are going to check a condition like, are there more attributes in the initial set? Any attributes are pending? If yes, then we'll go back for this selecting the best attribute by using a statistical measure, and then the same process will be repeated. If you take a simple example, this is an example which I obtained from the textbook. This is the initial attribute set. It has 6 attributes, A1, A2 and so on, A6. So initial reduced set would be set as an empty set, and this one, and the first iteration or the step, the best attribute would be considered and then included in this set, and then the second best attribute would be selected and included in this set. Like this we follow the approach until we meet the stopping criteria. So it has the 3 best attributes. Next heuristic method is a stepwise backward elimination. So in this again, so we have to initialize the reduced attribute set to be the initial attribute set. It is completely reversed to the previous stepwise forward elimination stepwise forward approach, and then select the worst attribute because we are going to eliminate the attribute, whereas in the previous case we are going to select the best attribute. But in this stepwise backward elimination, we are going to eliminate the worst attribute. So worst attribute also need to be selected using a statistical measure. So again we'll check, does the selected attribute exceed the stopping criteria or not? If so, yes, then will end. If not, so then we have to remove the selected attribute from the reduced attribute set, and then we have to check, are there any more attributes in the reduced set. If there are the more number of the still pending, right, still pending attribute sets, then we'll again go back and we'll check the worst attribute in the reduced set using a statistical measure. And again the same another example, like again the same initial attribute set. In this backward elimination, initially it would consider the entire set as the reduced attribute set. So this is entire set as it is in the initial attribute set. So then the worst attribute in this set is identified by using the statistical measure. So from this you can see here, worst attribute A3, that is being removed from this initial set, and then the A5 also been removed in the next iteration. So finally the reduced attribute set is going to have the three attributes A1, A4 and A6. Next, combination of methods, like both a stepwise forward selection, stepwise backward selection. So at each step the procedure selects the best attribute and removes the worst attribute from the remaining attributes. So in this case, it initializes the reduced attribute set to be an empty set and select the best and worst attributes in the initial set using a statistical measure. Then it will check the threshold. If so, then add selected attribute to the reduced attribute set and remove it from the initial attribute set. If that means the best attribute does not exceed the stopping threshold, then we'll go back and we'll check, add all remaining attributes in the initial working set to the reduced attribute set. So here in this case, like once we add the selected attribute to the reduced attribute set and remove it from the initial attribute set, again we'll check the condition, does the worst attribute exceed the stopping threshold or not. If it's so, then remove the selected attribute from the initial working set. So this is the procedure we follow in this combination method. And another very important heuristic method is a decision tree induction. Here you can see the structure looks like a flow chart, right? In this we can see some set of nodes, like there are some internal nodes as well as external nodes and branches, etc. Each node denotes the test. The test node denotes test on attribute. And the branches corresponds to the result. Result of test. Result of test. And then there are, and these are the attributes, means non-leaf attributes, like internal attributes, like this one and this one. These three are the internal attributes. This denotes the test on the attribute, whereas the leaf, those are used to denote the prediction. These are used to denote the prediction. So let us see one simple example of this decision tree representation of a simple data set. This is a decision tree representation of a data set. Like, given the weather condition, whether the team is going to play the tennis or whether the team is going to play or not a match. Like here, the first attribute is outlook, and then so based on the weather condition, whether it is a sunny, whether it is overcast or a rain, and again, and we are going to test whether the humidity is high or normal. Like if the outlook is rain, and again we are going to use the attribute wind, whether it is a strong or weak, so that you can see this, the leaf notes yes no represents whether the team played the match or not. Okay, so that this would also be represented in terms of if then else rules also. If outlook is sunny and the humidity is high, so the team did not play match. So similarly, if the outlook is overcast, so most of the time team play the match irrespective of the values of the sun and rain. So far we discussed about mainly the 4 heuristic methods, like stepwise forward selection, stepwise backward deletion, and combination, and decision reinduction. But we have to understand where to stop this. Like the stepwise selection or stepwise forward deletion, backward deletion, or the combination or decision reinduction, that is constructing the decision trees. So we should understand, or we should know where to stop the construction, or where to stop this selection criteria. So this selection criteria would vary from one method to another method, but the procedure may employ a threshold on the measure, so that once we reach the threshold, once we meet it, and then the construction or the selection, attribute selection criteria will be stopped. In some cases, we may want to create a new attributes based on others, like yesterday we already discussed. So such attribute construction can help improve the accuracy and understanding of a structure in a high dimensional data. So next, there are the two previous lecture we discussed about 2 types of like methods and data reduction, like parametric and non-parametric methods. So here the regression, linear regression and log linear regression models comes under the category of parametric methods. So there will be so we are going to approximate the data. So if you look at the simple linear regression here, and this red dots denotes the values, the data points, that is data points plotted on X 2-dimensional space, and there is an intercept term called as theta 1, the predicted value, the random error, and observed value. The simple linear regression is mainly used to identify the correlation, or to identify the lines, a straight line which exactly approximate the correlation between the X and Y. These are the X and Y too. Like suppose you can also take weight and height. You can also plot, you can collect the weight and the height values of set of people, and then if you could plot it, and then if you could able to draw a straight line, where that straight line, like suppose here we can also draw a straight line like this, and we could also draw the straight line like this, and like there are so many lines we could draw, but which is the best, which approximate the best, so that need to be selected. How we are going to select this? So here, like suppose these are the data points, let us say, and this is the line, the regression line. So we are going to check how this line best describe this data distribution. So the vertical, the difference between the actual value, like suppose this is actual value and the vertical difference, like, and this is a predicted value. The difference between these two And similarly for the rest of the values. If we add all the differences, and if we add all the differences, there are some measures we use like a sum of squared errors, etc. The difference is called as error. If we add, or if you use the formulas like a sum of squared errors, etc., and for which a regression line, line that value is small, and that would be selected as the best regression line. So this is the way we can select based on the simple linear regression. So we can select. Similarly, by using a multiple linear regression, here it is an extension of a simple linear regression. So where it allows the response variable y, that is to be modeled as a linear function of two or more predictor variables. Whereas a simple linear regression, the equation would be represented as y is equal to mx plus c, like y is a response variable and here x is response variable or the dependent variable, and here x is independent variable. And it is also called as a predicted variable. So, and there will be only one variable that is used to predict the response variable. But whereas in multiple linear regression, it is a linear function of two or more predicted variables. These are the predicted variables. There will be two or more number of predicted variables. So here you can see, and these are the three regression lines, like for each assignment scores, because here the hours studied and the score would be calculated based on the hours studied plus assignment. So for each assignment marks, so there is a separate regression line, so which depicts the correlation between the one response variable and two or more predicted variables. So log linear models approximate the discrete multidimensional probability distributions. So from the given set of tuples in n dimensions, for example, that is described by the n attributes, we can consider each tuple as a point in a n dimensional space. So log linear models can be used to estimate the probability of each point in this n dimensional space for a set of discretized attributes based on a smaller subset of dimensional combinations. So this allows a higher dimensional data space that is to be constructed from lower dimensional spaces. So log linear models are therefore also used for the dimensionality reduction as well as the data smoothing. So why these log linear models are used for the dimensionality reduction? Because the lower dimensional points together typically occupy the lesser space than the original data points. And let us see the uses of linear and log linear models. So these models can both be used on a sparse data. So the applications, though the applications are maybe limited. So both the methods can handle the skewed data. So regression does the exceptionally well compared to this log linear models. So regression can be computationally intensive when applied to the high dimensional data, whereas the log linear models show the good scalability for up to the 10 or more dimensions. So let us quickly summarize what we discussed in this lecture. So in this lecture, we discussed mainly what do you mean by the attribute subset selection, attribute subset selection. In this we discussed the few heuristic methods like the stepwise forward selection, stepwise backward elimination, combination, and then we discussed another important one is decision tree induction, and next we discussed the two parametric methods, those are simple, the regression methods, simple, and also the multiple regression, and also the log linear regression. So thank you for watching this video. So next video we are going to discuss about the histograms.